Very good evening, students. Welcome to the SBR online classes here. Uh, we are dealing with the integrals. In the morning session, we have discussed about the method of substitution there, and also I did 1 to 6 problems on the first exercise. So I have already solved the first exercise problems from 7 to 22 there. I have provided some homework for you people for the example 2, 3 and 4. So in the morning I did 1 to 6 and also I have given an example as a homework there. So in the morning section totally we have completed what here? First exercise problems. Now let us solve some second exercise problems. So before going to solve second exercise problems, you must know some of the note here, right? And also you must know about the formulas, 15 important formulas, and also today in the morning what we have explained about the things here with the help of method of substitution formulas also we have to remember, right? I told you if you remember the formulas and simple calculation, addition, subtraction, multiplication, division, if you know these two things, you can solve the problems very easily, right? So again, to solve the second exercise problem, some of the note you have to remember. What is the note? So why I am giving this note? Because second exercise problems will be of in this note form itself, right? Just see. Right? So most of the questions, most of the substitution questions of the second exercise will be of this form, right? In the denominator there will be a function and its differentiable factor will be in the numerator. So for these things we have to use this formula. For these things answers will be in this format here, log of mod of f of x here, right? And f raised to n of x into f dash of x, right? So there are some more substitution problems there will be in this format itself here. F raised to n of x into f dash of x dx. This will be the function and its differentiable factor will be the next to it, right? So for these things, what type of answer we will be getting here in this way here? F raised to n f of f to the power n plus 1 of x divided by n plus 1 plus c, right? So or else the problems will be in this format here. There will be one of the function. In this function itself, there will be another inner function there. This will be the hidden function in the particular function there. So for this thing, again what we have to do, right? Again what we have to do, for the inner function we have to make the substitution. We have to make some of the substitution for the inner function. So in this format it will be, right? So when you make substitution, its differentiable factor will be the next to it then. So in these three formats, you'll be getting the substitution form, right? In these three formats, you'll be getting the substitution form. So how do you obtain all these things? Just simply you substitute f of x as t. Answers will be in this format. Okay. Most of the problems will be getting in this way itself. Got it now? Just see here. If I have substituted f of x here as a t, put f of x as a t here, right? And this one, right? What happens? Differentiate. I'm changing x as t now. So differentiate with respect to x here. Differentiate with respect to x. F of x differentiation is what here? F dash of x. T with respect to x will be dt by dx. I told you x terms we have to take one side there. Right? X terms just take one side. Substitute in this LHS of the first integrand. What is the first integrand here? F dash of x by f of x. So f dash of x dx. Just see here. F dash of x dx is what here, friends? F dash of dx is what here? Dt. Right? So in the denominator, what is f of x? What we have substituted f of x as t. Right? It will be 1. Got it? 1 into dt. What is dt here? F dash of x dx. Its denominator is t. So it is looking like in this form 1 by x dx. What is the 1 by x dx integration? Right? Log mod x plus c. Agree? So it is in this format here. Now it was complicated. We have transformed into what a simple form. Now we can apply the formula here like this. It becomes log of t. Again, what is t here? Again, what is t? T is what here? Sorry, t is what here? F of x. Right? So in this process only the formula, the problems will be there of the second exercise. Right? So some of the problems will be of like this. Same procedure we have to maintain here. Right? So this is one of the note I have provided. Proof not required here. Right? I am telling you. In this way we are getting the problems. Right? Same procedure we have to do them. Similarly here also you can substitute same thing. Just now I have here, no problem. Let me write once again. Just substitute f of x as t again. So again differentiate with respect to t. So f dash of x, sorry, with respect to x, just differentiate. F dash of x here, dt by dx. Take x terms one side. Just now I did here. Same thing. Let's do. Right? Substitute the LHS of the second integrand. So what happens here? F of x, what I have substituted there? T. Right? Power is what here? N. So what is f dash of x dx? What is f dash of x dx here? It is dt. We know this formula, x raised to n formula. What is x raised to n formula, students? X raised to n plus 1 by n plus 1 plus c. This is the formula we know. Apply this here. It looks like same thing. T raised to n plus 1 by n plus 1 plus c. So now again we replace t as what here? F of x. So f of x power is what here? N plus 1. You have to n plus 1. So if you have the problems in this format, do the procedure in this way. So that's why I have given the note. Right? You can recognize the problems of second exercise in these three formats itself. Correct? That's why I have done the procedure here, general procedure. Okay? So this is a little bit complex one here. In the function, there will be another hidden function there. So in the innermost function, you have to make the substitution. If you make the innermost function as a substitution, as like this, what it becomes, you see, 5 f of x. If I have taken it as t, right? F dash of x dx, it becomes what here dt. Now it becomes what here easily integrable format. So in these three only, you will be getting the second exercise problems. Okay, just you write down these three notes there. Right? Okay, note. Okay, let me do the second exercise problem, students. Okay, one more thing I want to tell you people. Please do not panic about this chapter here. You will be getting 30 to 40 problems in each of the exercises there. No need to worry. Just remember the concept, right? If we have 11 exercises in the integration, means there are 11 different concepts there. All those concepts are very easy. Just remember the concept, right? I told you, just remember the concept and the formulas and simple calculation. If you know the concept and the formulas, each the whole thing, the whole integration will be very easy, right? There are most of the students, they feel hard by looking to the problems itself. The number of problems are more. No need to bother there. But all the problems are of same kind, right? If I am dealing with the first exercise, all the first exercise problems are of same kind. Now I am dealing with the second exercise problems. All the second exercise problems are of these kind itself here. Just you have to recognize it and you have to practice it. Got it? Understood now? So now let us solve the second exercise problems. No need to panic about these things there. Just constantly you have to practice the things. Okay? (7.2) Exercise 7.2. Integrate the main heading. Integrate the function integrate the functions in the exercise 1 to 37, right? So first one they have provided 2x divided by 1 plus x square. 2x divided by 1 plus x square. They are saying integrate this one. So sometimes they will be providing like this 2x divided by 1 plus x squared dx. Evaluate like this they provide. Or else in the word form they make you integrate 2x divided by 1 plus x square. So firstly what we have to take, whatever may be the question here, consider it as I. Let I is equal to whatever may be the question, consider it as I. We have to integrate. So integral of this one, integrand. What is the integrand now? What is the function here? 2x divided by 1 plus x square dx. Just see here, just you have to recognize in this format here, right? Either it will be in this form here, in this form, or in this form. Just here. Let's go for the first one here. See, firstly you have to look about the complex one. Again, in the numerator and denominator, which is the more complex one here? Um, uh, Whether you feel the denominator is a more complex one rather than the numerator there. So if which one will be the more complex one? If you feel the particular thing is complex one, you make the substitution there, right? So most of the thing it will be in this format. So the denominator will be the substitution, or else the complex things are in the numerator and denominator. If you find there, that one you have to substitute. Okay. So now let us substitute 1 plus x square as t. Right? If I substitute 1 plus x square as t, right? Put 1 plus x square as t now, right? So differentiate with respect to x. Differentiate with respect to x. What is one differentiation, students? 0. I am replacing 1 plus x square as t. I feel this one is a little bit complex than 2x. That's why. So differentiate with respect to x. One differentiation is 0. X square differentiation is what, students? 2x. Yes or no? Is equal to t with respect to x will be dt by dx. Now take x terms one side, students, here. 2x dx is equal to dt. Right? I told you that, right? 2x dx is equal to dt. Right? I told you that you should not write any constant things or negative things in the left hand side. You have to send back to the RHS side. But in the numerator, if you observe here, we require 2x there. Just keep 2x as it is. Actually, we have to send the numbers, all the things towards right side there. But there is a number 2 in the numerator. Just keep as it is. Okay? We can replace this differentiable factor. Now, let me call this as equation 1. So, substitute these things in the equation 1 now. So, 1 implies, what happens, students, now? What happens? Integration of 2x dx. 2x dx, just now we have done here. 2x dx is what here? dt. Right? We are changing variable x as t. 2x dx, it becomes what here? 2x dx, it becomes dt. So, in the denominator, what we have replaced here? t. Got it? So, numerator is 2x dx, we have replaced that t. The nothing there means what here? It is 1. So, 1 by t. Whether it becomes easily transformed, easily integrable form here? 1 by x dx form. So we know that integration of 1 by x dx is what here? Log of mod x plus c. Again. So now what happens? Integration of 1 by t dt in this format. What is the formula? Log of mod t plus c. But they have asked integrate with respect to x there. Right? So I need the answer in the form of x itself. This is not the answer. In the form of x, we have to mention that. So I equal to log of mod, what is t? What is t? 1 plus x square plus c. Got it? So this is the answer. So this is how we do by substitution method. Right? Just take down the notes. Next one. Second one, students, integrate log x whole square divided by x here. So I told you whatever may be the question, consider it as I. Consider it as I. What is I now? Integral of log x whole square divided by x dx. Okay, they told to integrate this one here. So integral of this one with respect to x. The variable is x, that's why we are integrating with respect to x. So now, if you look at these two things, numerator and denominator, so which one you feel the complex one, right? You feel the log x little bit complex than the denominator there, right? So if you feel that this has a complex one, just make the substitution there, or else you go through these three forms here. So it will be in this format. This problem is in this form here. In one of the function, there is another function. How, sir? Just see here. Look at the numerator there. Numerator is in this format here, x square. Numerator is in the form of x square. Instead of x, what we have? Instead of x, we have log x, right? Numerator is x square. Instead of x, what we have? Log x. So inner function is what here? Log x. So make the substitution of the inner function there, right? If you find the function as a composition of a function, then inner function you have to make the substitution. Just keep that in mind. So what is the inner function here? Log x. So put log x is equal to t. Got it? So differentiate with respect to x now. Differentiate with respect to x. Got as equation 1. So what happens? Log x differentiation is 1 by x. T with respect to x differentiation is dt by dx. Set x comes one side here. 1 by x dx is equal to dt. So substitute these things where? In the 1. Why we have to substitute all these things? It is little bit complex one. We have to make in the easily integrable format. That's why we are making the substitution, right? So now you see, students, right? Substituting in equation 1 here, I is equal to, right? Log x. What we have taken log x? T. T. It's a whole square, right? So let me write square here. T square. So now rest all things. What are the remaining things here? Divide by x dx. Rest all things I have replaced log x as t. It is a square. I have written square there. Rest all things. What do you find? Divide 1 by x dx. Yes or no? 1 by x. Here you see 1 by x dx is what here? Dt. So 1 by x dx. 1 by x dx. I have to replace it as dt. Got it, students now? Right? So log x whole square will be t square. I have substituted. Remaining thing 1 by x dx. 1 by x dx is dt. Now, whether it looks like this form here, this formula, we know that x raised to n formula. What is x raised to n formula, students? In the first 15 formulas, it is x raised to n plus 1 divided by n plus 1 plus c. Yes or no? In this format, it is little bit complex one. We have made easily integrable form. So what happens here? It will be 2 plus 1 divided by 2 plus 1 plus c. T to the power 2 plus 1 by 2 plus 1 in this formula here. So again, what happens? Let me write here. So I equal to t cube divided by 3 plus c. What is t, students? What is t? 2 plus 1 is 3 divided by, again 2 plus 1 is 3. What is t, students? T is log x. So log x, log of mod x also you can write, students. No problem. Whole cube divided by 3 plus c. Right? So this is the answer of the given integral. Right? Easy, right? All the problems are very easy. There are many problems, you should not panic. All the problems are of same kind. Right? You can write directly also there. Without substitution also you can do directly with the help of this formula. But we recognize in this way, you can apply this formula here. You can see here, f raised to n into f dash of x. Into f dash of x is 1 by x dx. F raised to n plus 1 divided by n plus 1 in this format itself. Right? You can recognize forms. You can do directly also. But if you do in the substitution way, it is well and good. It is a neat one. Right? same kind. Let me do the third one here, friends. Integrate third one. Main heading I have already written here. Integrate third one. What is the third problem? 1 by x plus x log x. 1 by x plus So what we have to do? We have to integrate this one. So whatever it may be considered as I, let I is equal to 1 divided by x plus x log x dx. So which one you feel the complex one? The denominator. Whether we have common in the denominator? Yes, x is common, right? If you have any common things, just take outside there, right? Whether x is common in this, just take outside. So after taking out the common thing, then you analyze it, right? X is common. Let me take x outside here. What remains here? 1. X 1 is x. X into log x is x log x. Right? Dx. 1 plus log x remains here after taking x common there. So now in this two things, which one you feel the complex one? This one. Make it as substitution. Right? Make it as substitution then. Just go for this one. So what we have to do now? Put what? This one. If you feel this one means just see the substitution there. What happens? 1 plus log x. Put 1 plus log x as what here? Change the variable. Change the variable x as what now? T. See what happens there. Let me take 1 plus log x as t. Differentiate with respect to it. Why we have to differentiate? Because here we can replace t there. The rest all things will be there in the form of x there. We have to make it as t. For that purpose, here we have dx. That's why we are differentiating there to convert this in the form of t. So what happens? 1 differentiation is 0. Log x differentiation is 1 by x. T differentiation with respect to x, dt by dx. Now cross multiply. I told you x terms we have to make one side and dt. Right? So 1 by x dx is equal to dt. So now replace all these things. Replace all these things in this equation 1. The given integrand, right? We have modified like this. Substitute all these things in the equation 1. See what happens the equation 1 here. So equation 1 implies I is equal to just see students 1 divided by what is 1 plus log x students? What is 1 plus log x? T. Just write on t. Numerator is 1. Write on 1 here. Denominator 1 plus log x is what here? T. In the denominator itself we have to write. It is in the denominator, write down in the denominator itself t. So now rest all things. What are the things left out here? 1 by x dx are left out here. I have to replace, right? 1 by x dx we are finding here. This is a differentiable factor there. 1 by x dx. For every function we will be getting the differentiable factors. So what you get? 1 by x dx as what here? Dt. So replace 1 by x dx as what now? Dt. See, this one is the integrand. Now it had become simplest form, right? So again we know this formula. We know that what is the formula? 1 by x dx as log of mod x plus c. So son, this formula you know. Apply it. It is with respect to t. What happens now? Log of mod t plus c. Understood? So I equal to log of mod. What is t, students? What is t? 1 plus log x. So most of the students they keep answering here itself. No, further you have to do. Again you have to replace t as 1 plus log x. Why? Because they have asked with respect to x. They integrate with respect to x. Variable is x. So we have to show the answer in the form of x, not in the t. Again you have to replace back. Okay. So this is the answer. Log of mod of 1 plus log x. Easy, right? All problems are of same type. Just copy these things here. Fourth one, students. Now let us look here. Integrate. Integrate is the main heading. Integrate sin x into sin of cos x. Sin x into sin of cos x. So what do you feel this one here? What do you feel? Whether you feel that this sin of cos x is little bit complex one? Yes. So it is a composition form. It is a composition form. What I told, I given the three nodes, right? In the third node, it is looking like third node there. So one of the function is hidden inside here. That is cos x. Cos x is hidden inside the sin x there. It is a composition form. So inner function, what we have to do? Substitution. Yes or no? So just see there which one is complex. That one you have to make the substitution. Always the inner function we have to make the substitution. If you look at these type of problems there. So what we have to do, whatever may be the integrand, consider it as I. Whatever may be the question, consider it as I. I is equal to antiderivative of integral of what is sin x into sin x. Sorry, sin of, it's sin of, right? Sin of cos x. Right? With respect to x, we have to do integrate with respect to x. So now, call it as equation. Call it as equation 1. Right? So in you look that you can find that this one is composition form. Inner function we have to make the substitution. Keep that in mind. Inner function, always inner function we have to make the substitution. What is the inner function here? Cos x. Make it as substitution at t. Differentiate with respect to x, students. Differentiate with respect to x. What is the cos x differentiation? Minus sin x. Whereas cos x integration is plus sin x. But we are doing differentiation here. So cos x differentiation is minus sin x. T with respect to x is dt by dx. Send dx left side is cross multiply. Minus sin x dx is equal to dt. I told you you should have only the x terms in the LHS side. Whatever may be the constant terms or negative terms, send back to the RHS side. So negative term is there, just send back to the RHS side. How we can send back? Just multiply minus 1 on both sides. Multiply minus 1 on both sides, friends. What happens here? Sin x dx is equal to minus dt. Right? Only x variables should be there in the left hand side. So these will be the differentiable factors here of the given integrand. Now substitute all these things. Substitute all these things in the equation 1. What happens? Equation given question there, right? Sin just here. Sin x is there, no problem. Let us look at this complex one here. Sin of cos x. What we have substituted there? Cos x we have substituted as t. I'm focusing on this one, students. Now I'm focusing on this one. Cos x, what we have taken it as t. So this is sin is there. Write on sin of. Sin of cos x, what we have substituted here? T. Cos x, what we have substituted? T. This term I have written like this here. Sin of cos x is t. So what are the remaining terms? What are the remaining terms? This one and this one are the remaining terms there. Sin x and dx are the remaining terms. Whether those things are the differentiable factors? Yes. Those things are what here? These things. Sin x and sin x dx are the differentiable factors. So these things what I have to replace? Minus dt. Automatically it gets there. So into this sin x into dx. Sin x into dx I should replace it as minus into. It's an into, right? It's an into, not minus dt. Into minus dt. Okay. So now plus into minus minus. Take minus outside the integral. It's an into minus dt. So take minus sign outside there. So sin t dt. Whether we know sin t integration, whether we know sin x integration, what is the sin x integration, students? What is the sin x dx integration? It is minus cos x plus c. Whether we know this formula, sin x integration is minus cos x. Derivative of sin x is plus cos x, but integration is minus cos x. So now I keep I as this. Minus is there, write on minus, right? So what is sin t integration? What is sin t integration? Sin t integration is minus cos t. So wherever minus is there, I told you we have to put the bracket. Minus is there, write down minus as it is. Integration of sin t is minus cos t. You are getting the answer as minus. Whenever you are getting the minus as the answer, put the bracket there. I told you many times there. So put the bracket minus cos t. So minus into minus again, it becomes plus cos t. Cos t plus c. So again t. After integration, we have to write plus c as the integral constant there. So now again we have to replace t as what here? Cos t. So what will be the total answer now? Let me write here. So I equal to cos is there, written cos t. What is t? T is what here now? Cos x. Cos of cos x plus c. Plus c. Right? So this is the answer. This is the answer for the given integration. Whether it is easy, right? So just see the integrand here. You feel this as a little bit complex one. Make it as substitution. That too what here? This function is of composition. If it is of composition, in the function we have to make the substitution. Keep that in mind. So in the function I have made it as t, differentiated, we got differentiable factor, replace differentiable factor sin x dx as minus dt, right? Sin of cos x I have taken as t then. Minus you send back outside there. Sin t integration is minus cos t, minus of minus plus cos t there. T again I have replaced it as cos x. Cos of cos x is the answer. Got it now? I need the answer in the form of x. We are integrating with respect to x. Answer at last we need in the form of x itself. So that's why most of the students they keep answer up till here. No, we won't give full marks there. So we have to express again t as the x. After this step, you have to write this one. Okay. Now let me go with the fifth problem. Integrate sin of ax plus b into cos of ax plus b. Integrate sin of ax plus b, right? Integrate sin of ax plus b plus cos of ax plus b. Of course, these things. There we go. Okay, students. Now you see, students here. If you whatever may be the question, consider it as I, right? I is what here? Integration of sin of ax plus b cos of ax plus b, right? Now we know, students, we know the basic idea that sin x differentiation is cos. We know some basic thing, right? Sin x differentiation is cos. So what we have to do? We have to make the substitution here. Put sin of ax plus b as t there, right? Call it as equation 1. Put sin of ax plus b as t. What happens? Differentiation of this. Differentiate with respect to x. What happens? Sin differentiation is cos ax plus b. Again, it is a composition form. Inner function differentiation. A as it is chain rule, by the chain rule, sin x is cos x. Inside the function is what here? A constant as it is, x differentiation is 1 plus b differentiation is 0. Right? Is equal to t with respect to x is dt by dx. So send x one side here. What happens here? A into 1, a plus 0, a into cos of ax plus b, a cos ax plus b. Now I am cross multiplying this here, it becomes dx. I told you only x factors here dt, only x factors should be there in the left hand side. Remaining things I should send back to the RHS side. So what happens now? Cos ax plus b dx is equal to dt by a. Right? We know, we have the idea that Sin x differentiation is cos. That's why we have substituted directly. Here I told inner function we have to make the substitution. If I make the inner function as a substitution, even though you are getting the answer at last, it takes more time then. But suddenly we can recognize by saying this thing as sin x differentiation is cos. The total thing I have taken as t there. Okay. So now you see, replace all these things in the equation 1. Replace all these things in the equation 1. What happens? You see, I is equal to. So sin x, sin of ax plus b. What I have taken here? T. I took sin of ax plus b as t. Now you see, what are the remaining things? These are the remaining things. Cos of ax plus b dx. These are the differentiable factors. Yes. Cos of ax plus b dx is the differentiable factor. What it is now? Dt by a. So I have to write it as dt by a. Got it? These things I have to replace it as dt by looking these substitutions there. So 1 by a is constant. Take outside. 1 by a is constant. Take outside. In the next step, I is equal to 1 by a is constant. Take outside the integration. So what remains? T into dt. So we know this formula. What is the formula? We know here integration of x raised to n formula. What is the integration of x raised to n formula, students? X raised to n plus 1 by n plus 1 plus c. Whether we know this formula, integration of x raised to n as x raised to n plus 1 by n plus 1. Here, instead of x, what do we have? T. Instead of n, what we have? Then nothing there is, means what here? N is 1 here. So it is like this. Differentiation of x is 1. But differentiation of x is what here? X raised to 1 plus 1 by 1 plus 1. Similarly like this. What is integration of t with the help of this one here? 1 by a, t raised to 1 plus 1 by 1 plus 1 plus c. Most of the students, what they do, they write it as 1. Differentiation of t is 1. No. Sorry, differentiation of t is 1 with respect to t. But integration of t is what here? T to the power 1 plus 1 by 1 plus 1. Got it? Differentiation of x is 1. We agree. But integration of x is what here? It is in this format. Integration of x is x raised to 1 plus 1 by 1 plus 1. In this way we have to write. Okay. So that's why I have written like this. So what happens now, students, here? 1 by a. What is t? Okay, let me write like this here. T to the power 2 divided by 2 plus c. So 1 by a into 2. A into 2 is 2a. What is t now, students? What is t? What is t? T I have taken it as sin of ax plus b. It is a square here, so that's fine. Sin square of ax plus b plus c. C is the integration constant. After the process of integration, we have to express integral constant as plus c then. So 1 by a into 2a is 2a. T I have replaced as sin of ax plus b. It's a square, that's why it becomes sin square. So this is the answer. Easy, right? Yes or no? So because, no need to write because there. If you know the formula, directly you apply it. For you people, I have written the formula there. Okay? Okay, now let us go with this sixth problem. Root of ax plus b. Root of ax plus b. Solution. So whatever may be question, what we have to consider here, let I is equal to root of ax plus b dx. So which one you feel here? This one you feel difficulty, right? Just replace it as t then. So called as equation 1, put ax plus b is equal to t. right? What happens now? Differentiate with respect to x. What happens? A as it is constant, x with respect to x is 1, b with respect to x, this is a constant thing, it becomes 0, and t with respect to x becomes dt by dx. Send cross multiply dx here. A into 1 is a plus 0 is a into this cross multiply, a into dx is equal to dt. I told you only x factors should be in the left hand side. Rest all things you take outside, just send back to the RHS side, cross multiply. Substitute all these things where? In the equation 1. 1 implies, equation 1 implies I equal to integration of root of this little complicated one, that one we took it as the inner function. Whether it is a composition form, yes, it is a composition form. It looks like root x. Inside the root x is a x plus b, that's why we took it as t there, right? In the function, we have to make the substitution always. So now what happens? Ax plus b, what we took? T, right? So what is dx now? Remaining things are what here? Ax plus b as t. Remaining things are dx. Dx is what now? Dx is dt by a. We have to write down the differentiable factor. Differentiable factor dx. Differentiable factor dx is what here? dt by a, right? So now a is constant. A is constant. Take outside the integral. It is in the denominator. So that's why 1 by a we have to take outside the integral there. This root t I can write it as t to the power 1 by 2. Agree? Agree? Root t can be written as t to the power 1 by 2 dt. So again let us use the same formula here. Whether it looks like x raised to n formula, use the same formula here. Use the same formula, students. So I equal to 1 by a, right? Apply the formula now. It looks like x raised to n. This one, right? It looks like x raised to n. What happens? X is what here? T there. So what happens? T to the power 1 by 2 plus 1 whole divided by 1 by 2 plus 1. Yes or no? Integration of x raised to n form is x raised to n by x raised to n plus 1 by n plus 1. It is in that format I have applied here. Plus c. After applying the integration, we have to write the integral constant plus c. Further, you simplify this one here 1 by. So now you know these type of forms you have already did in the first exercise. Write down the directly the things here. So t to the power half plus 1 is how much here? 1.5 means 3 by 2. Yes or no? Half plus 1 is 1.5. 1.5 means 3 by 2 plus c. Further you simplify. It flips here. This 2 goes to the numerator. What happens? 2 times 3 is t to the power 3 by 2 divided by a into 3 is 3a. Yes or no? Plus c. So this 2 goes to the numerator. 2 times t to the power 3 by 2. A into 3 becomes 3a. Right? You know all these things there. Simple. Again t I have to replace. You should not keep this answer up till here itself. You have to convert this t again as x. Why? Because they asked with respect to x there. So I 2 times. What is t now? What is t I have replaced here? T I have replaced it as ax plus b to the power 3 by 2 divided by 3a plus c. Understood? So this is the way to solve the substitution method. This is a process, right? If you practice more and more, this problem you can solve within 2 minutes there, right? You might have seen I took many steps there. I took more steps to solve this one here. Within 2 steps, you can do this problem. If you practice more once, you will be getting idea how to solve those things. So how do I get within 2 steps this as an answer? We already know this formula, right? Whether we know this formula, what is ax plus b whole raised to n formula? What is ax plus b whole raised to n formula? Ax plus b whole raised to n plus 1 divided by n plus 1. Here in the function is ax plus b. Differentiation of this is 1 by n. You can use this formula directly also, right? But I am doing the substitution methods to have the clear idea I am doing in this procedure itself. You can apply this formula directly. What happens? You see, root can be written as raised to 1 by 2 there. Apply this x raised to 1 by 2 plus 1 by 1 by 2 plus 2 divided by a you are getting. Same answer you will be getting within 2 steps there, right? So just now you people are learning the things. Just go in the proper way, right? This is the procedure how to solve the substitution method. Okay. Whether all these problems are of same kind, right? Same procedure. All the problems are of same procedure, right? All are of same kind. In this exercise there are 39 problems. You should not feel it as hard. They make you 100 problems also. Just it is in the substitution form. If you know the concept, all the 100 problems you can solve it, right? All problems are of same kind. That's why whatever how much they may give the problems, just we have to stick with the concept and just we have to go on simplify it, right? All the things are similar, right? Let us do the next one here. Which problem we did now? Sixth one. Now let us do seventh one. What is seventh problem, son? X times of x plus 2. X times of x plus 2 then. Integrate x times of root x plus 2. So what we have to do now? Put integrate. Let whatever may be the question, consider it as I. Let I equal to integration of x times x plus 2 dx. Right? Just see whether you feel that this root of x plus 2 is a little bit complicated one. So that you have to make that one as a substitution then. This one it is in this formatting root x. So again x in this x what we have x plus 2. It is a composition form. If it is of composition form, inner function we have to make the substitution there. If it is of composition form, inner function we have to make the substitution. What is the inner function here? Inner function is x plus 2. Put x plus 2 as t. Right? So now differentiate with respect to x. Differentiate with respect to x. X differentiation is 1 plus 2 differentiation with respect to x is 0. Constant differentiation is 0. Here t with respect to x is dt by dx. So cross multiply 1 plus 0 is 1 into dx is dx is equal to dt. Now let us replace all these things in the equation 1 called as equation 1. So 1 implies now you see the students integral of root. Under this root x plus 2 what I have taken? Under the root I have took x plus 2 as t. Right? What are the remaining terms? X and dx. See the differentiable factor here. Differentiable factor is only dx. Differentiable factor is dx. Dx I have to replace it as dt. So only dx I am replacing it as dt. So again what is left out here? X is left out. So what to do for this one here? X is left out, right? Root of x plus 2 is t, dx I replace as dt. So again x is left out here. Yes or no? X is left. What to do for this? X again you have to replace it as t. How? We took this as x plus 2 as t, right? Whether we can simplify further this one here. I need x here. I have to make this x as t then. Just send it towards left side. What happens? X you keep here, 2 you send towards left side. What happens? T minus 2 becomes. Now x is left out here, write down there. Instead of x, what we have now? T plus 2. Write down here. T minus 2. Now totally it becomes what here? Let me write clearly here. Root x plus 2 I took it as t, and dx we know it as dt. And how to do for this x here? How to do for this x? For this x, and let me take 2 towards left side there, right side there. So it becomes what here? X is equal to t minus 2. Replace this x as what now? T minus 2. How we got this? By the substitution itself. So x I have to replace it as t minus 2. Got it now? Right? Little bit different from the previous 6 problems. Right? Here it is little bit different, right? You have to practice more this one. Right? You have to practice more. Now, I equal to. Now multiply t minus 2 into root t. T into root t is t root t. Right? Next, minus and plus is minus. 2 into root t, 2 root t. Now simple calculations, right? Simple calculations we have to do. Rest all things you know how to do all the things, right? So what we have to do now next? I equal to integration of. So t, where do t? Root t, I will be writing it as t raised to 1 by 2. T as it is, root t I will be writing it as t raised to 1 by 2 minus 2 times t, root t again. Root t I am writing it as t raised to 1 by 2 dt. Now, see students here, what is a raised to m into a raised to n? It is a raised to m plus n. Yes or no? It looks like same thing. A raised to nothing there means what here? It is 1. A raised to m into a raised to n is a raised to m plus n. It becomes what here? A raised to 1 plus half. 1 plus half minus 2 times t raised to half as it is dt. Right? So now, what is 1 plus half? 1 and a half. 1 and a half means 3 by 2 minus 2 times e raised to half dt. Just here, this looks like in this format here, x raised to n dx is x raised to n plus 1 by n plus 1 plus c. Yes or no? Integration of x raised to n form. So what happens now? Integrate it this one here. T raised to 3 by 2 plus 1. You did in the first exercise there. Divided by 3 by 2 plus 1. These type of things you did in the first exercise problem. Minus 2 constant as it is. Write down 2 constant as it is. Again this one, t raised to half. Again it looks like in this way here. Yes or no? Again you apply in this manner. T raised to half plus 1 divided by half plus 1 plus c. After process of integration, at last you should mention the integral constant c. Right? So now, again further simplification. Further you simplify. After this one, further you simplify here. I equal to t raised to 3 by 2 plus 1. Take 2 as LCM. 3 plus 2 is 5. 5 by 2. Write down directly here now. You know the addition, all the things. Directly write down 3 by 2 plus 1. 5 by 2. Again divided by 5 by 2. 3 by 2 plus 1 is 5 by 2. Minus 2 times. Half plus 1 is 1 and a half. 1 and a half means what? Nothing but what here? 3 by 2. Denominator also. Half plus 1 is 3 by 2 plus c. Now this goes to the numerator. Flip it this one. What happens? 2 goes to the numerator. 2 times t raised to 5 by 2 divided by what remains here in the denominator? 5. Now this 2 goes to the numerator. 2 into 2. Flip this one. 2 goes to the numerator. 2 into 2, 4. I'm writing directly, students. T to the power 3 by 2 divided by 3. Right? 2 into 2, 4. T is 3 by 2 by 3 plus c. So most of the students, they keep answer in this way here. No. Further we have to simplify. We have to replace back t as what here? We have to replace back t as x plus 2. Right? We need answer in the form of x there. So that's why 2 times t is what now? T is what here? X plus 2. X plus 2 to the power 5 by 2 divided by 5. Minus is there at minus 4 times. T again t, what is we have to replace? X plus 2 to the power 3 by 2 whole divided by 3 plus c. Right? So in detail I am solving the things. You can You can skip some of the steps. You can do directly also, right? You can skip this step here directly, right? If you do all these things, half plus 1 is 3, but you can skip this step here. Directly you can integrate here, and you can skip this step. Directly you can write this one here. After adding, you get 5 by 2. 2 you take from the numerator. You can skip this step. You can write directly, right? After simplification, replace t as what here x. You have to replace back, right? All problems are of same kind here, right? Same question. After this, you have to write this one. Okay. Please, students, you have to practice daily. Then only you feel integration as easy there, right? So we have many problems. By looking to the many problems there, you feel harder. You should not panic, right? Actually, integration is very easier than the differentiation, right? Just only remember the formulas and simple calculation. Just here, I have applied only the concept here, and simple calculation we did here. Addition, subtraction, LCM, all the things there. Yes or no? If you remember the concept, then you can do any type of problem. Eighth one, x root of 1 plus 2x square. Tell me what will be the substitution here? What will be the substitution? Anyone? Right? So integrate this one. So whatever may be the question, consider it as I. We have to consider it as I. Just see here in the previous step, each and every step I have written I there. I equal to I equal to I equal to I equal to. What is equal to answer? That is the most important one here. That's why I took I equal to here. This is the thing what they have asked the question here. In each and every step we mention that I equal to I equal to. Right? So what integration is what here? X times root of 1 plus 2x square with respect to x. Right? So I saw in the last year one of your senior, right? What he has done. He was frustrated to write this integral sign in each and every step. What he has done, instead of writing all these things, he made what here the whole step as a single integral sign there, right? Had made like this. He got frustrated to write integral sign in each and every step there. So he solved throughout the problem in the only one integral sign there. So this type of things you should not do, right? We won't give any marks for this one here, right? So do not try it like this there, right? We have deducted full marks there, right? Just have the patience and do the things, right? Okay. Now let us do this thing, right? Same concept. So again in this. You see here, this one is little bit complex one, so we have to focus on this. This one, it is in the format of like this, root x. Yes or no, root x. What is the inner function of? What is the inner function? Inner function. Instead of x, what we have? 2x square. 1 plus 2x square. So inner function, we have to make the substitution. If it is of composite form, inner function, we have to make the substitution. So put called as equation 1 now. So put 1 plus 2x square is equal to t, right? 1 plus 2x square is equal to t. Differentiate with respect to x. One differentiation is 0. 2 constant as it is. X square differentiation. What is x square differentiation? 2x. 2 as it is. X square differentiation is 2x. T with respect to x is dt by dx. Send dx cross multiply here, 2 into 2x is 4x, dx dt is equal to dt minus here. I told you only x factors should be there in the LHS side. Remaining constant things, negative things, we have to send back to the RHS side. So x dx you keep as it is. Constant things cross multiply to the RHS side dt by 4. Substitute all these things where? In the equation 1. Substitute all these things in the equation 1. 1 implies I is equal to integral of this root, right? Root 1 plus 2x square. What is 1 plus 2x square now? T. 1 plus 2x square is t. So root this one is t. What are the remaining things now? X and dx are the remaining things. So whether these are the differentiable factors? Yes. X into dx. X into dx is the differentiable factor. What is the differentiable factor now? We have to replace dt by 4. So x into dx, I have to replace it as dt by 4. dt by 4. Again, so we made in the simplest form. Now again, 1 by 4 I is equal to 1 by 4 is constant. 1 by 4 is constant. Take outside. Integral of this root t. Root t can be written as t raised to 1 by 2. Agree? Root t is written as t raised to 1 by 2 dt with respect to t as this. Root t is written as t raised to 1 by 2. 1 by 4 is constant. Take outside the integral. It looks like in this formula x raised to n dx. What is the x raised to n dx formula? X raised to n plus 1 by n plus 1. Yes or no? This formula we know. Apply the this type of problems you did in the first exercise. You should recognize all the things, right? And also in previous problems also we did the same thing here. What happens? T raised to half plus 1 divided by half plus 1 plus c. Further simplification very easy, right? So I equal to 1 by 4. T raised to half plus 1 is 1 and a half, that is 3 by 2. Half plus 1 is 1 and a half, that is 3 by 2. Take the LCM, you get 3 by 2 then. Plus c. 2 goes to the numerator now. So 1 by 4, 2 goes to the numerator. 2 times t to the power 3 by 2 divided by 3 remains. Plus c. Yes or no? 2 goes to the numerator. Here 2 ones are, 2 twos are. So I equal to t to the power 3 by 2 divided. 2 threes are 6. Yes or no? What 1 into t raised to 3 by 2, 3 by 2. 2 threes are 6 plus c. So after simplification, we have to replace back t as x there. So t is what now? 1 plus 2x square. After simplification, replace t as x. T is what now? 1 plus 2x square. 1 plus 2x square whole to the power. What is this one here? 3 by 2 whole divided by 6 plus c. This one. Right? So after simplification, we have to replace t as again 1 plus 2x square. Right? Whole to the power 3 by 2 is there. And 3 by 2 whole divided by 6 plus c. C is the integration constant. Got it now? 4x plus 2. Right? Integrate this one. Solution. Whatever may be the question here, consider I. Right? I, it's a 4x plus 2 into root of right. Now you see, if you whether there is a common here, if you find any common thing, you take out there, right? Whether there is a common thing here, yes, 2 is common. 2 2s are 2 1s are. Take common. If you find any common things, you just take it as a common thing. Right? 2 is common, right? Take 2 as a common. What happens? 2 how much are 4? 2s are 2x plus 1. Here root x square plus x plus 1 dx called as equation 1. So now you see in this integrand you feel this one as a little bit complex one. So again this one is look like composition form. It looks like root x. Again, the root x inside the root we have the x. X has what here? X has x square plus x plus 1. I told you, if it is of composition, inner function we have to make the substitution. Right? What is the inner function here? X square plus x plus 1. Put x square plus x plus 1 as t. Right? Put x square plus x1 plus 1 as t. So now differentiate with respect to x. With respect to x. X square differentiation, students. What is the x square differentiation? 2x. X differentiation 1. 1 differentiation 0 is equal to t differentiation with respect to x dt by dx. Yes or no? So in a function we have to make the substitution, right? So send cross multiply here, send to the LHS side. 2x plus 1 0 is 2x plus 1 into what here? Dx dt. So replace all these things where? In equation 1. So 1 implies I equal to, right, integration of, right? 2 is there. Okay, let me write. This one I have substituted, right? Let us focus on that one. This one I have substituted as t. Let us focus on that one. So that is root. It is root. This one, what we have replaced as t. Right? Let us focus on this. It becomes root t now. So what are the things left out? This one, and this one is left out here. I have replaced it as root t. These things are left out. See the differentiable factor here. What is the differentiable factor? 2x plus 1 dx is dt. 2x plus 1 dx. Whether we have 2x plus 1 dx. Yes or no? 2x plus 1 dx. We have to replace it as dt. So this vanishes and this vanishes. It replaces as what here? Dt. So one of the, again what we remains here? 2. 2 is remaining right on 2 itself. Got it? 2 is remaining right on 2. Right? So root is there, root right over here. X square plus 1, x square plus x plus 1, I replace that t. So again remaining terms are over here 2x plus 1 into dx. 2x plus 1 into dx. We got the differentiable factor as this one dt. So just replace it. Right? But it becomes simplest form. So 2 is constant, take outside. You know further things how to do. I equal to 2, you take outside of it. Root t. Root t is written as t to the power 1 by 2 dt. 2 is constant thing, take outside integration. Root t is written as t to the power 1 by 2. Again same thing there. This formula. Again the same formula x raised to n dx. X raised to n plus 1. X raised to n plus 1 by n plus 1 plus c. Use this formula. T raised to half plus 1 divided by half plus 1. This 2 as it is. Plus c. After integration process, write down plus c there. Right? Integral constant. 2 times. So t to the power half plus 1 is 3 by 2 divided by 3 by 2 plus c. 2 goes to the numerator now. 2 2s are 4. 4 times t to the power 3 by 2 divided by 3. Simplification. Plus c. Right? After simplification, we have to replace back t as what here? We have to replace back t as x. So what is x there? So x variable here, that is 4 times x square plus x plus 1 whole to the power 3 by 2. T as this much. Whole to the power 3 by 2 as it is, whole divided by 3 plus c. Most of the students they keep answer up till here. No, we have to do further. We have to replace back t as in the form of x there. Got it? All are the same kind, same thing, same procedure, right? Our 10th one students, important one, little bit Important one here, 10th one, 1 by x minus root x. Little bit different one. Just here. Here, if you see this one, here 2 is common. We took 2 as a common here. Whether we find any common thing here in the denominator, right? You feel that root x is complicated, you can substitute root x as t there. But here, whether we have any common thing in this x minus root x, whether we have any common thing, yes, we have the common thing there. Whether we can express x as root x into root x, yes or no? What is root x into root x? Is root x whole square. Root x into root x is root x whole square. Square and root get cancels. What remains here? X. X can be expressed as root x into root x. Whether you can take root x as common now. X is written as root x into root x minus root. Whether we can take common now? Yes. If you have any common thing, you have to take outside of it. Right? So now, solution. Before going to the substitution, you have to see all the things there. Let whatever may be the question, consider it as I. I is what now? 1 by x minus root x dx. So I write x as root x into root x there. Right? Because this one, because x is written as root x into root x. Right? You can write directly, but in detail I am solving there, right? You can write directly also there. You can take directly root x as common. Take root x as common now. What remains? 1 time of root x in the first term minus 1 remains. Right? You can write directly also. You can take directly root x as common. What remains here? Root x minus 1. Now, in these two things, which one is a little bit complicated? This one. Root x minus 1 is a little bit complicated than this one here. Yes. So make this as substitution here. Make this as substitution. Right? So put root x minus 1 is equal to t. Right? Put root x minus 1 is equal to t. So differentiate with respect to x. Root x differentiation, students. 1 by 2 root x, you know the differentiation formula. Root x formula is 1 by 2 root x minus 1 differentiation with respect to x is 0. T with respect to x is dt by dx. Yes or no? So send cross multiply here. 1 by 2 root x cross multiply. 1 by 2 root x minus 0 is 1 by 2 root x. Cross multiply into dx is equal to dt. So I told you that you should have only x variables in the LHS side. If you find any constant things or negative things, you have to send back to the RHS side. What happens now? This can be written as 1 by root x dx is equal to 2 dt. Shall I write here? Whether you can see or not. This one I can write here, right? 1 by root x dx. Send this 2 towards RHS side. It becomes what here? 2 dt. So below this, you write this one here. Below this one, this is the step. So I should not keep any constant things or negative things in the LHS side. Only purely x variable should be in the LHS side. Right? Send back this cross multiply, 2 goes to the RHS. After this, you write down this step. This is the differentiable factor of the substitution. Right? So substitute all these things in this equation 1, students. Substitute all these things in the equation 1. What happens? One implies what happens, students, now? I equal to integration of 1, numerator is 1, write on 1 divided by. So let us focus on the substitution. What we have substituted? X minus root x minus 1 we have substituted as t, write on t. It is in the denominator, so I should write t in the denominator. So what are the terms left out here? The terms left out is 1 by root x and dx. 1 by root x and dx is left out. So whether 1 by root x dx is the differentiable factor, yes, after this step I written this one. So 1 by root x, 1 by root x is left out and dx is also left out. So 1 by root x, dx is what here? 2 times dt. We did right. Yes or no? So replace 1 as it is. This one we replaced as t here, and 1 by root x dx is 1 by root x dx is 2 times dt. 2 times dt. Replace all these things. Replace this one and this one here. Right? What happens? 1 by t, 2 dt. So 2 is constant, take outside the integral here. It becomes 1 by t dt. You know this formula. Integration of 1 by x dx is log of mod x. Right? Log of mod x plus c. Yes or no? It is simplified. It is simplified in this way. So I equal to 2 times log of mod t plus c. 2 times log of, again, t we have to replace bracket as x. That is root x minus 1 plus c. So this is the answer. Whether it is easy, right? Whether it is easy? So in the first itself, you can't know how to do all these things. Then just go and practice it. You'll be recognizing the things. You can judge correctly. Just 11th one. 11th problem students. Integrate x divided by root of x plus 4. X is greater than 0. This is the condition we have put. Integrate x divided by x plus 4. This one is the integrand. Practice more students this problem here. So whatever I give some important problems there, you have to practice more. There is a chance of asking these questions in the annual examination. So now consider this as I. Whatever may be question, consider it as I. Let I is equal to x divided by root x plus 4 dx. Right? Now, just see which one is little bit complicated one. Denominator. You feel this one here, right? So again, see the denominator is of root x form. Again in the root x, what we have x plus 4. It is a composition form, right? So inner function we have to make the substitution. You know the things. It is same as 7th problem you see. 7th problem and this problems are similar. So inner function. What is inner function here? Put x plus 4 is equal to t. Inner function we have to make it as t then, right? So differentiate with respect to x. Right? What is equation 1? So x differentiation with respect to x is 1. 4 differentiation with respect to x is 0. T with respect to x is dt by dx. Cross multiply. 1 plus 0 is 1. 1 into dx is dx. dx is equal to dt. Substitute all these things in the equation 1 now. So let us focus on the substitution. What we have substituted x plus 4 here. So let us focus on this one now. So this one is what here? T. It is in the denominator, right? It is in the denominator. It is a root. It is a root. Write down root. X plus 4 is what here? T. Replace it as t. So what are the things left out now? Dx and this as x. See the differentiable factor. Whether we have x dx as the differential factor, only differentiable factor is dx. Only differentiable factor is dx. Replace dx as what now? dt. Right? Replace dx as dt. So again, what we left out? We left out with what here? X. Right? So after replacing x plus 4 as t, root t becomes here. Dx I have replaced it as dt. So again we left out with this one here. Again we left out with x. So what to do for this one x here? We left out with x, right? What to do for this one here? Same thing we occurred this type of situation we got in the seventh problem there. We did seventh problem. Seventh problem also same thing, right? So x, what to do for this x? For x, what we have to do? Send this 4 towards left side, right side. So what happens? X is equal to 4. You send there, it becomes t minus 4. This type of thing we did in the seventh problem now in the same manner itself. Substitute all these things in the integrand there. Whatever you left out, again you make adjustments in the substitution itself there. Okay, integration of x plus 4 is t, I have to substitute, is under the root. Dx is dt, I have to replace d. Again for x, what you do? Again for x, we have to take the help of substitution there, send 4 towards left, right side. What you get? X value as x is in the numerator. X is what now? T minus 4. T minus 4. Same thing we have done in the seventh problem, right? They are similar. Now, as we know, a plus b by 2 as a by 2 b by 2. A by 2 b by 2. No, split it. Split it. So it is written as t by root t minus 4 by root t dt. Right? I hope you understood all the things. Now, simplification. Only simplification you have to do. T divided by root t is written as t raised to half. 4 root t is written as t raised to half. And taking more steps you can do directly also, students. You can directly take in the numerator there, t raised to half. It becomes what here? T raised to 1 minus 1 by 2. Whether you know this thing, a raised to m by a raised to n is a raised to m minus n. It is nothing but 1. 1 minus half, a raised to m by a raised to n in this format. Minus 4. If you take this towards to the numerator, it becomes t raised to minus half. Minus 4 is constant. 1 by t raised to half is t raised to minus half. Right? dt. So again, it becomes what is 1 minus half? 1 minus half is half. Minus 4 times minus t to the power minus half. Right? So now this is in this format. This is in the form of x raised to n dx. We know this formula, x raised to n plus 1 by n plus 1 plus c. Apply that. Rest all things you know how to do the things. T raised to half plus 1 divided by half plus 1. This formula, right? It looks like same thing here. Minus 4 constant as it is. Again, this is in this format here. What happens? T to the power minus half plus 1 divided by minus half plus 1 plus c. Next one. These both the things is in this format. I have applied the formula there. So rest all things you do it. So I have used here. Let me write here. Otherwise you will be getting confused there. I have applied this formula. I have applied this formula there. Right? So further calculation let me do here. T raised to half plus 1. What is half plus 1? 1 and a half. That is 3 by 2. 1 and a half means what here? 3 by 2 divided by 3 by 2. Minus 4. T to the power. What is 1 minus half, students? Minus half plus 1 means 1 minus half. What is 1 minus half? 1 minus half is half. Similarly in the denominator also. 1 minus half is half. Plus c. Now 2 goes to the numerator, it becomes 2 times t to the power 3 by 2 divided by 3. Here 2 goes to the numerator, 4 2s are 8. Half divided by 1 plus c. Right? 2 goes to the numerator, 4 2s are 8. Now again you have to replace back t as what here? You have to replace back t as x plus 4. So 2 times x plus 4 to the power 3 by 2 t as x plus 4 divided by 3. Minus 8 times t as what here? X plus 4. Half to the power half. This is the answer. Easy, right? Easy. Only calculations you have to do. Right? So it is a little bit lengthy one. Do not bother. Right? But Remember the concepts. Calculation you can do this, right? Try to practice it. If you practice, you can take less time to solve in the annual examination. Okay, you can do faster, right? If you practice more. No problem. Faster. Okay, students, it's a time now. We'll be solving some more problems in the next class. So I did how many problems here? 12 problems. So I did 12 problems. Remaining problems I'll be doing in the morning section as well as evening section. Tomorrow I'll be finishing this second exercise. We have more problems. No need to worry. Just practice daily, constantly. Right? If you have any doubts, you can ping in the WhatsApp group. We'll be giving you the reply there. Okay, thank you. Have a nice evening. We'll be meeting you tomorrow 9 a.m. Thank you.